So now we're going to talk about standardized normal form. In this example, again, let's say I have the mean value as 35. You can again go back to the same example where we have taken the average compute time of all the TechLove employees. And we said that the standard deviation is, let's say, the value 5. Now, if there is any person X, if there is any value X 43.25, which is the commute time of a person, and we want to find out from here that what is the probability, let's say we want to find out that what is the probability that the commute time for employee is going to be less than or equal to 43.25. How we can get that? Now, number one thing is that you can standardize this data. Let me first explain you what I mean by this. If you look at 43.25 on the uniform data, so I'm assuming that my data is uniform, which we have learned in the last session. Now, in this case, it is going to be at a difference of 8.25, right? And on the right hand side. Now, this difference 8.25, but if I look at the standard form, I have to divide it from the standard deviation, which is sigma, which is what? 5. So in this case, my value will come out to be 1.65. This value of 1.65 is also called as Z score. Okay, this is the standardized format of the data. So I can represent my Z score as the value X minus nu divided by sigma. This is the formula for getting any Z score. Means I'm just standardizing the data in basically before we can perform anything else. In fact, this is going to really help us even determining the probability for our question what I have asked. Okay, I will tell you how. It's very simple to do that. Now here, so again, remember that when I say probability, I'm talking about cumulative probability. So I got the value of Z score like this. Now this you can intuitively understand. If my value is positive, definitely my basically Z score is positive. That means my value is lying on the right hand side. But if in case if it comes down to be negative, if my Z score is negative, that's also possible. Then in that case, that means that I'm talking about the left hand side of the uniform distribution. Now, how to get the probability for this particular question? For doing this, we will take the help of Z score. Let me explain you how you can use this. So in order to use this Z score, let me open up a Z table and show you up how that looks like. So this is my Z score table, and in this Z score table, I have to get the value of 1.65. How we generally look at this? So here we have to look at 1.6. So let me show you so we will see here, which is 1.6. So we will look at this particular row and we look at this particular column. So we got the value of 0.9505, right? 0.9505. This is the value which is the probability. So I got 0.9505. This is the answer for the probability that the commute time is less than 42.5, okay, or 43.5, whatever the question was. So I think it was 43.25, correct. So it's 43.25. So this is how you will be computing this particular data. So quite interesting, right? You can see that you can just standardize the data. In fact, I will be explaining you in more detail later that how important is this Z score value, how important is this standardization before we will be using any machine learning algorithm. So we will be learning that in detail. So you will get a very good insight that why Z score is really important from the machine learning perspective, and in what situations you should be applying the Z score on the data before you apply any sort of machine learning algorithm. So this part is going to come later. So for now, just understand that what is Z score, this is called standardization, and how you can get cumulative probability for this Z score value.